Hey everyone, hello and welcome to today's webinar, How to Conduct Drone Inspections in High-Risk Environments, Part 2 of 2. We'll get started here in just about 30 seconds. We're going to give just a very small window of time for anyone who's running late or having technology issues to arrive. So just bear with us for just one moment and we'll get started presently. Okay, let's go ahead and get started. So again, today we'll be talking about how to conduct drone inspections in high-risk environments. We had part 1 of this webinar 1 month ago. In part 1, we covered case studies. We looked at specific missions that presented high risk, right? That were problematic environments that required planning, careful execution, lots of communication with the client to make sure to surface any possible hazards on site. Today we'll be covering more of the documentation and the sort of abstract when it comes to high-risk environment missions. So planning, project management, execution, also what you can do in advance to be ready for an emergency. So what you can do on the preparation and planning front so that if something unexpected arises, you'll be ready for it, as ready as you can be. So that's part 2. We're excited to go ahead and get started. So today we have with us Eli Moselle, the CEO of Halo Robotics. We have Charles Ray as well, the training manager here at Flyability. I'll be your host. My name is Zach Dukowitz. I'm the content marketing manager at Flyability. Just a few sort of housekeeping items before we get started. One really big one is to ask questions at any point during the webinar. We may not be able to answer your question live in that moment in the question pane, but if you ask the question, we'll be curating everyone's questions. We'll be throwing them into a document that we have to make sure that we answer them at the end during the Q&A. So please, at any moment, if you have a question that pops into your head, use that question pane, hop in there and type in your question. Feel free to use the chat pane too as well. Another question we often get that we want to make sure to answer here up front, yes, there will be a recording available afterwards. So if you'd like to review the webinar, if you'd like to share it with someone else, if you'd like to keep it for yourself for future reference, we'll be sending that out within the next 24 hours after the webinar ends. And then here's the agenda. I'm going to go over the agenda and then I'll present our first speaker, which will be Eli. So in the beginning of the webinar, we're going to have me introducing. So that's the introduction, the first 5 minutes. Then we'll hand things over to Eli. Eli will present on high-risk missions, planning, project management, and execution. Charles will follow up with a presentation on key checklists to make sure you're ready for a high-risk mission, especially thinking about emergency scenarios. So thinking about all the contingencies, those things that could pop up unexpectedly. And then the last portion of the webinar will be devoted to a panel discussion. So without further ado, I'm excited to introduce Eli Moselle. So Eli is the CEO of Halo Robotics. He's been in that position for 5 years now. In that role, he's guided both huge and medium-sized organizations in their work to incorporate drone technology into their workflows. And you'll see in a moment when Eli presents, the list of their clients is long and impressive, and he's going to share a little bit about that. And he's helped make companies' processes more efficient and safer. In addition to his expertise in drone solutions, Eli also has worked providing drone-related trainings to help companies fully realize the potential of new robotic solutions. So without further ado, I'm excited to hand things over to Eli.
Hi everyone. Thanks very much, Zach, for the kind introduction. Yeah, I'm very grateful to be here, and thanks for the opportunity to talk a little bit about our experience in high risk environments. And it's also I'm very honored to be here with Charles Ray, who actually trained me um, some time ago, and so it's also an honor to present here together with my trainer, sort of the dojo karate kung fu black belt master in these things. So yeah, really looking forward to getting into it. The topic today is operating in high risk environments. I think this is a great topic because it's high risk environments is also where generally there's a very dramatic high return on investment in terms of the cost savings that are achieved by reducing non-productive time, reducing direct costs on scaffolding inspections and rope access, and then also the tremendous improvements of safety and real outcomes in terms of reducing incidents and manned entry into tanks. So yeah, we can move to the next slide, Zach. I mean, really, when we talk about the title in terms of operating in high risk environments, and the longer title that we can present here is really how to operate drones safely in high risk environments again and again and again in order to really sustainably build a drone program and get real value from it. In terms of my own experience doing this, Halo Robotics, where our company is focused almost fully in Indonesia. I've been here in Indonesia for 10 years and over half my life in Southeast Asia. Halo Robotics, our company, we represent many global leaders in drone technology in Indonesia as a distribution and service partner, including Flyability, and that's a key strategic focus of our business. I think some of the other areas that Halo Robotics works in, we definitely, a very key focus is inspection and asset integrity management, but we also do work across every industry in every drone vertical where drones are able to support efficiency and safety. So that includes surveying and mapping, and now LiDAR more and more. As well as intelligence, surveillance, reconnaissance, public safety or emergency response, and then also working directly with companies in terms of understanding how the drone works in sort of the broader ecosystem of other tools and digital transformation objectives that they have. Yeah, we can move to the next slide. I think the key point that I would make, and the reason I mentioned that we're working in these other industries, and here's just an example of some of the customers and clients that we're working with. The key point of this is not that Halo Robotics works with all these companies. The key point is I think some of the stuff that we're covering today is really a standard that is useful and that can be applied. These are practices that can be applied across any type of drone, in my opinion, can be applied across any type of drone application in basically any industry, whether you're talking about policing, power line transmission inspections, LiDAR surveying, some of this stuff that we're covering today generalizes over into all of these applications and anywhere that drones can be usefully applied. Next slide. And that is definitely very true when it comes to high risk environments. So here we've just got a couple of examples. I mean, the classics are in oil and gas, in mining, and heavy industries, where you can see here a couple of examples that were provided by Flyability here. That's in chimneys, boiler tanks, gas pressure vessels. We just recently completed some operations in HRSG, or heat recovery steam generation units, and gas gas strippers and cooling towers. There's really so many places where these drones are being applied, and it's quite dramatic. The return on investment and the improvement in terms of process efficiency and safety. it's very, very significant. I think important from across many industries. The thing though is that where that value is also achieved is also in very high risk environments. And so the key is, I think, in my presentation today, and we can move to the next slide in terms of talking about the agenda. The key would be really moving beyond, I think, some of the classic questions about the safety of the drone and is it safe, and some of the classic questions that typically we find, people who are just getting into it or using it for the first time or thinking about purchasing the drone. Some of the classic questions, addressing those and then moving beyond into like, some of the questions that we experience as like truly the real risks in terms of preparing for the operations. And then the second thing is the data that is being produced by these drones, which is like the key deliverable, like managing all of that data, getting the data, localizing, the data in terms of matching where the photos and the visuals are coming from and locating that on the asset. So getting value from the data and then really being able to do that again and again and again, to come back to that asset 6 months later and repeat that, so that your results that you get from, point A and point B are comparable. This is where we think that there is, a lot that can be, talked about, and we have some experience doing that I'm happy to share. So just in terms of reviewing the agenda today, we'll go over some of the initial concerns and hazards that people typically are concerned about and want to address. Some of the key risks that we really deal with in our experience in terms of getting value and managing safety. And then, what do we do in terms of what is it? And when we talk about a project management approach, what does that really involve? In terms of the preparation and the method statement, like let's get into it and really like look at what is a method statement and how do we use it, preparing and also managing change during an operation. And then some of the other risks that we typically encounter while we actually do operations. Some of them are even quite non-technical risks. And then in terms of managing the data and repeatability, which I think is really key. So next slide, please, Zach. All right. So again, I think this is probably number one question that we are asked, and not just when it comes to inspections and asset integrity management, but just generally in all kinds of high risk industries. The question is it ATEX rated or explosion proof, or can we operate it when there's a presence of flammable or explosive vapors? So I'll just get that out of the way. A couple other kind of key questions in terms of the drone, and questions that people are initially, some of the resistance points that especially like HSE or asset managers are quite concerned about in terms of just using the drone in that area. Just taking it point by point, first point I would make is that gas-free, no drone, not the Flyability Helios 2 and not DJI drones, and I personally don't think it will be possible for drones to fully be explosion proof, just given the fact that they have motors that are spinning, and some of the characteristics of motors make it, for me, something that we can't anticipate that they'll be explosion proof. However, the good news, and I think is important to mention, is that drones can definitely be operated in high risk environments, and including in oil and gas, and including in like clean fuels and LNG, where there's real concerns about flammable vapors. The note is, how do we address that is basically the environment must be gas free, or at least a gas detection sensor needs to indicate that the gases are below tolerable threshold levels. And then in terms of ATEX zone management, so ATEX is a zone-based management system where like ATEX zone 1, ATEX zone 2, ATEX zone 1, if you can imagine like an oil rig, would be like around the well pad, where there's constant, in terms of the definition, there's a constant presence of flammable or explosive vapors. So ATEX zone 1, drones cannot and should not be operated in ATEX zone 1 environments. But ATEX zone 2, so for example, like the helipad or some of the surrounding areas of an oil platform, ATEX Zone 2, drones can be safely operated in ATEX Zone 2 environments, which are defined as, occasional presence of flammable vapors or, explosive vapors. So what we would do in these types of situations when required is to obtain something called a hot works permit. And whether you're a drone service provider or the drone program is internal in your company, this is something that can be used to process site access and operations in these types of high-risk environments. Is a hot works permit, same permit that is used for flash photography and other technology. And in our experience, as long as we can, be attentive to those factors, we can, generally safely operate in, in oil and gas and in other environments where that's a big concern. Next slide, please, Zach. So this is answering some of the other key questions, and I've given an example here on the right that I'll talk about in just a quick second. But the next big concern is generally, like, what if the drone gets stuck, or how are we going to recover it, or what are the obstacles? For example, if we enter into a gas stripper where there's some plates, in different levels within that pressure vessel, what if we get stuck, or how are we going to deal with that? And that definitely is something to address. The number one way to address this, and Charles will also discuss this, is preparation. What is the recovery plan? What are the emergency scenarios that we need to attend to? And I think, there's just no way around it. That preparation is the number one way to make sure that, by the time you actually go to do a drone operation, that, this is very well planned out, and you know exactly how you're going to fly that asset in a systematic way that really reduces and mitigates that risk significantly. For example, if you have a stripper with 4 plates that are breaking up the levels, to arrange, multiple flights, one flight for one section, one flight for the next section, one flight for the next section, that there is a way to address that in terms of preparation. But yeah, that's definitely a key thing in terms of risk management to attend to, but it is a manageable risk. The other thing is temperature. So there's the example on the right is an FPSO vessel that stores crude bulk. It's bulk crude oil storage, and there's tubes that heat up the oil so that it's sufficiently viscous to move around and pump. And this is actually an operation that we decided was not feasible because basically the entire top section of that basically compartments do go above 50 degrees Celsius. And we noticed that does actually have an important safety implication in terms of there's lithium polymer batteries on the drones. We need to attend to that. And then also the performance and the air features, the way that the drone actually moves through the air, actually changes when the air is very hot. So we decided that, and we worked with the asset owner to determine that, in fact, this was an operation that wasn't feasible for that reason. So I think temperature is something to attend to in some operations, and just to note that that's a 50 degree Celsius max, but otherwise, these drones can definitely handle very rugged conditions. Water and moisture, direct water contact, that's a no. The drones are not Helios 2 drones, not IP rated technically, so you definitely want to avoid that unless it's just an emergency scenario. But some moisture, it would sort of depend. I mean, we're in Indonesia; it's very humid here in general. So I've written that this is a depends no. Again, this is the point. The point of this list is to go through some of the very basic questions before we get to project management. Dust and debris is another kind of key risk. I actually think that this is where this is not just okay, but this is actually a great use case. An important point about the Helios 2 is that it really handles dust and debris very well. The LED lights are like, this drone was made to tolerate very rugged environments, and so boiler tanks or underground mines, stopes and structures in underground mines are places where you get a lot of dust and debris, and that's exactly where the drone really comes out and shines. So I would say that this is not just a manageable risk, but actually a good use case for the drone. Hazardous and toxic materials, that's okay. So again, as long as they're not flammable or explosive. I'll give you an example, is like an acid gas stripper, which is an asset in the oil and gas industry. Typically, when they do an inspection, they will not just wait for it to be gas free or flush it with nitrogen, but they will also need to. Traditional method would be you'd also have to clean that out so that people can walk, go in and be safely. There's corrosive materials, etc. So that is something, again, where the Helios 2, is meant for those types of environments. So yes, as long as it's gas-free, the moment that it is gas-free, that's the moment that you start to do drone inspections on those assets, as long as the materials and hazardous toxic materials aren't obstructing the actual inspection that you're trying to conduct. Key risks that I'd put here in terms of our experience that has come up actually is altitude. We work it's funnily enough in Indonesia, there's actually some mountain ranges where it's very cold, and actually the assets and locations are at very, very high altitude, like 2,700 to 3,300 meters above sea level. And this actually is something that it is fine. The Helios 2 can handle that. Most drones can, but it is something to think about in terms of it will affect battery life, and basically the drone is putting more work into staying into flying, and so it will reduce battery life, and you should plan for that in terms of the flight planning. So these are basic questions. We can move on to the next slide, Zach. So now, got that stuff out of the way, and this is like if we go and have that kind of stuff is the stuff where, like, if we have a meeting with an asset owner and it's the first time that they're using drones in a turnaround or in their environment, then those are typically the questions that will come up. These are the risks to manage that come up in our experience that I think are very important, and that will be important both for the asset owners, the drone operators, drone service providers. This is just something that I think is just very general and actually like the real risks in terms of our experience. Number one thing is just in terms of failure to prepare. So like so much in terms of risk management, risk identification, risk mitigation, emergency scenarios, getting good data reliably, anticipating some of the non-technical slowdowns, that will happen when you actually get to site and, actually need to like access the asset. So much of this stuff can be addressed by really, really detailed preparation, both in terms of the drone operators' preparation as well as their coordination with the asset owners and the other project sponsors and people who are involved in the project. So I'll cover more about that in my presentation. And scope creep. I think this is just a key executional, like an operational risk is scope creep, is that it happens so many times that we are on site and, you inspect one tank and this has gone, as an example, and this has gone really well. And because there's still some time left in the day or the shift, the users or the asset owners or operators want to introduce some additional scope. It's like, well, while you're here, why don't we do this other thing? And while there's time, why don't we hit this other thing? And it can be real inspection work, where it's kind of like, let's go and inspect this other asset while we still have time in the day, or it's really important to do this other thing. And it can also be things like, oh, our CEO is on site and actually would like to see a demo applied, at this other place. Can we just do that real quick? I think just scope creep is just a huge, real operational risk. I think it's such a fundamental operational risk in terms of that's where accidents will happen, in terms of management of time, management of fatigue, that not having prepared for the other thing that you are going to do is is such a key thing to be aware of, and why I think it's key is because the frequency of this risk in terms of like its occurrence it's very regular that this will happen. And so it's just something that I think is very important to attend to. How we deal with that in a systematic way that organizes things with all of the people involved in the project is through method statements, and I'll talk about that in a moment. Some of the other risks, in terms of time management, include sort of non-technical slowdowns on site and time pressure. So like one of the things about high-risk environments is they're typically asset-intensive environments where there's a lot of high-value assets, and therefore a lot of restrictions in terms of site access, even within the site, actually going to the specific asset and doing an inspection there. There's typically like equipment inspections or checks that need to be done. That the amount of standby time that is caused by this and sort of non-technical factors that actually, in terms of like administration or bureaucracy or HSE policies, that's all fine and good, but it's just something to really factor into operational planning in high-risk environments. Is typically there is quite a bit of non-technical stuff that needs to be allocated for time, and if it's not allocated, that can create time pressure, and then time pressure is really something that can cause problems with the actual drone operation. And then the thing is, moving on a little bit from the actual execution side, I think a lot of attention is typically given to like operating the drone, and is the drone safe, and if we use the drone in this high value, high risk asset, is it going to be okay? I think, but let's not forget the key question is about the data. The drone is a tool to collect data, and so if it doesn't collect the data that we need, or if we're not able to go back and get that same type of data again, that's actually a real problem. And so, there's data risks and data requirements in terms of doing the operation to actually get the data that is required within the time that it is required, and then also localizing the data. So like, again, the drone is taking, let's not forget, the drone is taking a bunch of 4K video or photos that then go into a file folder. And then how to actually identify that like image 507 is actually, from this particular location is actually the asset defect that we need to put into the inspection report. So localizing the data is a key risk. And then repeatability, so not being able to go and do that again is another big problem. So next slide, please. In terms of doing this, so taking a project management approach, I think I'll talk a little bit about the method statement. A project management approach is basically that you would identify all of the people involved in a project sponsors or asset owners, people who are endorsing the project but kind of in the background, the actual project manager who's supervising the execution, pilots who are involved, administrative and commercial people, like HSE, people who are doing the on-site permits, budget holders or budget, PICs, and then people who actually receive the data and, use the data. And then, we use the method statement to organize scope, as well as timeline deliverables and data procedures, as well as risk. So next slide, please. So again, preparation, this is something that Charles will also talk about, but preparation is just absolutely key. This is going over the actual method statement itself. This is the real method statement that we actually use. So that again identifies all of the personnel who are involved. So like I mentioned, project sponsors, project managers, pilots, all of that. Key point about this, this list, this is basically just, it's a project charter. It basically summarizes the project, all of the risks that you would identify in just like one page is kind of summary. This is also where it's very important to put the assumptions in terms of what do you assume when you actually do this project that is required in order to be successful. So this is where we would say, state the assumptions that it's assumed to be gas-free or flushed with gas before the operation begins. It's assumed to be non-operational so that the assets aren't being operated. One thing that actually has come up in our experience is important to make sure that like the assets are pumped of water and other major debris or like ancillary equipment has been removed so that the inspection can actually be done. And some of these other, assumptions that go in, it's very important to like state them so that your scope is organized in terms of like what is required to actually do a good inspection of that asset. Next slide, please. Okay, so here in terms of next section of the method statement, and again, this is going over like real examples of actual method statements and why it's so important. So is the next section is schematics, blueprints, maps, diagrams, document references, basically anything that is going to give you an indication of like what you are dealing with and the scope of work. And this is really important, especially if that asset is not previously, proven to be inspected with drones. So like boiler tanks, proven, gas pressure vessels, big like LNG tanks, crude oil tanks, like this stuff is all like, I would say now very well proven, applications for the Helios 2. But then what do you do in terms of encountering like a new asset? And as a successful drone program, whether you're a drone service provider or the asset owner, you'll want to introduce more and more scope of where these drones can be applied. So how do you handle like new assets that have never been done before? This is where it's important to like really put as much information as possible down into the method statement, including schematics that list like where the points of entry are, how this asset works, visual stuff like what the stuff that you're seeing right here is an HRSG. It's this heat recovery steam generation unit. We had never done that before, but with enough preparation and information from the asset owner, we were able to do the inspection safely and efficiently. Yeah, I think we can go over to the next slide and continue from here. So from that information, you can see again here, so then the next part of the method statement is scope of work, and scope of work as it relates to the flight plan description and the timeline. And here it is very important to be specific. And again, this is a key part of the preparation. And when we talk about the level of granularity or specificity that is required, is literally every single battery that is used has a plan. So here again, you can see that on the bottom right, there's the HRSG unit that we talked about. There's one manhole entry for this compartment. If you see on the bottom right here, and that's a superheater or a large like basically panel, tube structure where every single flight in that asset has been planned, every single battery. So we know exactly how many batteries, how many flights, what flight, what number of the flight. So if we see like a defect in the inspection imagery later, we can actually localize that. So we know that like, oh, that photo is from flight number 104 in, X area. So we can actually localize that information later. So very, very important. And you can see in the top right there, listing, exactly how many flights are going to be used for what, and exactly how much standby time may be required. Next slide, please. The final section is a risk assessment and mitigation plan. This is also an essential part of every method statement, and generally every single operation is different, so you will need to like attend to this. I think many people here will be familiar with the general concept of like a risk matrix in terms of there's hazards that are identified. Hazards are basically dangers or problems that can occur, and the point of a risk management is to quantify that in terms of when we talk about risk, we're talking about quantifying the likeliness and the severity or the consequence, and that's what a risk matrix will do, is likeliness of how likely something is to occur and the consequence of if it does occur. And then basically once you have that number, then you go about your mitigation plan, which is all of the different steps you're going to take in order to mitigate that risk. And here again, I think it's just very, very important in terms of the preparation to be detailed. You can see in the bottom here, we've even listed like bring a knee brace, or any other type of support need. Like level of granularity is very important. So yeah, the risk assessment and mitigation plan also a very important part of the preparation. So that concludes that on the method statement. And next slide, I'll talk about a little bit how this is used. So we use the method statement as a very important part of the planning, the coordination, and execution of an operation. So we use it as a live document. So like, let's say, so we are a drone company and we work with asset owners. So that's the way that our conversations are happening when we do planning. And so what will typically happen is the asset owner or the users from that company will have an interest in, doing something, using the drones as part of their inspection plan. And then what we will start to do is bounce around drafts of the method statement, which confirm an alignment of understanding, and a scope of work that everybody's mutually understands will be done, right? So it's very, very important in terms of alignment. And even if you are, if we're talking about people, I think many people on this call, it's an internal drone program where you yourselves are operating, the drones for your company, which is the asset owner. I think it's still very, very important that there's many people who are related to, project sponsors or other users or PICs within your company, where it's very important to align understanding about what is going to be done and secure approval for that. And so the method statement, we just use this, we bounce drafts back and forth in order to document the discussion. It's kind of like minutes of a meeting, is that you have a meeting, you review further, make changes in the method statement, send the method statement, the updated draft of that, in terms of confirming understanding about what is going to be done and what is not going to be done in terms of what the scope is and what it is not. And so here again, I listed this, these are flares that would be a general visual inspection, not using Helios 2 drone. The point that I'm making here is that the method statement can be applied across. We use it for LiDAR surveys, general visual inspections, security operations. Like it is a generic thing, a generic practice that is so effective and important across any type of drone application that you are doing. The other key thing is using it as a reference. So version documentation, so that if there is a dispute or some problem later, you can go back to previous versions of the method statement and say like, okay, we talked about that, and then the change was this, and then the change was this, and you can actually record back to like different points of the conversation about a project so that you have a reference, and that if you did something, in terms of, that was very successful, in an operation, you also have a reference to like what you did at that time, what the best practice was. So it's important to use version documentation as well. And yeah, in terms of using the method statement as a reference, it's important to, just organize every piece of data or photo or piece of information that has ever gone into the creation of a method statement and keep it organized in file folders, because you never know when you're going to need it. Next slide, please. Method statement, there are many parts of it that we've sort of talked about before in terms of managing non-technical factors and the assumptions that are going into the operation, preparation, and execution. I think the key point I would make here in terms of risk management and managing, scope creep, which is the huge risk that I identified earlier, is that a method statement is a very effective tool for managing scope and addressing additional scopes that happen in an operation. I'm not saying that we are not open to like doing additional scopes if it makes sense and if it's feasible and if everybody's on site and all of the people have approved and all of the conditions are right, then we're happy to potentially take on more scopes, as should you be, in terms of maximizing the benefits of the drone. But the key is that the way we use it as a standard operating procedure is that if there is a new scope, we will make a new method statement for that new scope. And then the whole process of making a method statement gets everybody involved who needs to be involved. So the project sponsors or the asset owners, people who are related to the permits, people who are related to the budgets, everybody who should be involved in that project is involved in the creation of a new method statement, which if all of the conditions are right, a method statement can be done in, half an hour. Right? Like it doesn't take a long time to make it, but we use that as a key document for managing scope and adding new scopes if there potentially are any. I think there's a little bit of time pressure on my own presentation, so I'll just keep it moving right along.
Yeah, just a quick time check, and I'm sure you have a clock in front of you as well, but we have about 20 minutes left in the presentation.
Roger that. I think just the last key point, and this is coming to the final points that I would make, is that about data and repeatability. So let's not forget that the point of a drone is to collect large amounts of data, and that is good because it produces a large amount of data. The problem then is actually about data management. Is again, they're creating so much data, and let's not forget, that these are just like files in a computer. So managing that, and also the inspection reporting that comes out of that, it's actually a big risk. Like I think data risk is a real risk, and we do put it in our risk assessments, is localizing the data and then managing the data for long-term use. I think it's very, very important to attend to. Again, here's an inspection report from a Pertamina oil tank that I can share this particular operation, the asset owner that we work with. And this is just one page of a 700-page report that was taken from one oil tank. Like the point being that that's a report that was taken from one specific point of time, and we're going to go back in 1 year, do that inspection again, taking that report from the first time and being able to compare it to the second time so that there's actually a meaningful comparison or an analysis, is where you go from just doing inspections to asset integrity management. And being able to actually make decisions about that asset, over a long period of time. And so, in my opinion, that's also that's something to attend to in terms of the success of drone operations, but also a key risk to identify in terms of being able to use a drone again and again and again in high-risk environments and actually have it create value that is meaningful for the actual asset owners. Next slide, please. So yeah, I'm just attending to time, so so I'll also say the same thing on this slide, is that basically one of the key things is repeatability. And in order to be basically a lot of the risk, when people talk about doing drone operations in high risk environments, it's typically a lot of risks that are focused on the single point of evaluation, right? Like going in at one particular turnaround operation and then using the drone to get a good inspection that particular time, right? But I think in terms of asset integrity management and going back to what's the point of a drone program or using the drone is to create real value over the and particularly over the long term. And so we want to be able to repeat that evaluation again and again and again. And so repeatability is the key thing to attend to, and again, in terms of the success of a drone operation, but also the risk. So being able to do the same thing twice, I mentioned it in the other slide, is one is of course use method statements, but also in terms of just anticipate the large amount of data that is going to get created by these drones from the beginning. Like that is just key, is that from the beginning, you can start to set up systems internally in terms of managing file folders, who has access to these file folders, how that data, what's the plan in terms of how you're going to share it in the organization. So organizing all of the stuff that goes into a preparation in terms of the data, and then the inspection records that are then generated from those inspections, managing that in a very systematic way. If there's defects or if there's maintenance that is done on the asset as a result of the drone inspection, managing that type of data as well can also be very useful. And then again, if you're planning on going back to the asset and doing this again, or over a sustained period of time, managing the pilot competency and currency. And then something I would just mention, and again, in terms of repeatability, is like every single operation, you're going to learn something that you didn't know before, or you're going to have some thought about well, this could be done better next time, right? And if that's the case, then document it. Really get rigid about documenting and creating what we call guidelines. And the guidelines are basically like company regulations, right? Is that we adapt the guideline into the next, we formulate them like laws, like guideline number 1 of 2020 on confined space inspection in HRSG, right? Like very specific guidelines, so that when next time we go to do an HRSG, even if it's a different pilot, we can have a standardized way of doing that. I've talked a lot. I think that is my last slide, and I will pass it over at this point. I apologize, I'm running a bit on in time. Thank you very much for the presentation. I'll pass it over to Charles, Zach.
Thanks so much, Eli. I just want you to know we've been getting lots and lots of people chiming in saying how valuable what you were presenting on is. So thank you. A lot of information to digest in those slides. One thing to remind people, the slides will also be available after this webinar. So if you want to go back and peruse what Eli put together, and obviously the recording will also be sent to you. So that'll all go out in an email that you'll receive tomorrow. So don't worry, this information will be there for you to go over again. So thanks so much, Eli.
Thank you very much, Zach. Thanks everybody. Thanks for your time.
So of course, we're running a little short on time. Charles will present briefly on checklists and preparing for all cases, hopefully, right? So that if an emergency comes up, you're ready. And then we will go a little over trying to answer all of your questions that have been coming in. So just a brief introduction for Charles. As Eli said, Charles is the black belt of trainings at Flyability. In his work as a training manager, he's conducted numerous inspections himself, as well as demonstrations, of course, trainings. He's led trainings of over 400 people in environments including container ships, ship ballasts and holds, gold and nickel mines, sewers, offshore oil rigs, and many other potentially high-risk scenarios. So I'm going to go ahead and hand it over to Charles. Charles, you go ahead and take it away.
Yes, thank you very much, Zach. Well, you can go to the next slide directly. And again, to the next slide, please. So on the last webinar, we already talked about the importance of a good preparation, and I got a bit over why it is important to be well prepared. This is a list of a couple of things why it's important to be prepared before you arrive on site. As Ellie said very well, good preparation is going to be the key to any kind of inspection. And my point will be on this presentation is more why it is important to be well prepared. And actually, it's important to know your environment because you will be able to react much faster if something goes wrong. So if you know perfectly your environment, you know that you have water under you and you start losing the signal, well, your reflex must be to go up with the drone and try to place better the pilot or the remote control or this kind of small thing that you will be able to do quickly and react quickly if you know well your environment. Could you go to the next slide, please, Zach? So basically, you will be able to be more focused on the tasks that you are doing, so you'll be faster to react to any problem. You will be able to think much faster on what's the best move, what could be going wrong. You try to mitigate all those problems, and then if your pilot is very confident about his environment, he will be less stressful and he will be able to take decision much quicker and good decision, and that's sometimes life-saving for the job. You can go to the next slide, please. So last time we went over 4 checklists. Basically, the idea is to get prepared before you arrive on site, and when you are on site, you try to follow the exact plan that you have defined sometimes weeks before. And this way, you just have to readapt to small unforeseen things. And what we will do now is to check 1 or 2 videos that will show example of completely unforeseen thing that happened and how we managed to react to those situations.
Charles, just a reminder that you get automatically muted when the video starts.
Yep, thank you, Zach. So this was an inspection in a sewer. So you can see the drone going straight down. So you can see the range extender here too, that is placed in the middle of the sewer, so you have a good connection all the way. And we thought that it would be the only challenge would be, well, only, it's already difficult to fly in a sewer, knowing that if you fly too close to the water, you will have some drops on the lens. But here's a problem that was not foreseen was mist, as it's warm in the sewer, but it was in the winter outside, so it was really cold. You get some condensation on your lens, and you are at the end you are completely blinded. So here we temperated the drone in the sewer for a couple of minutes. So the temperature of the drone was, and the lens of the drone adapted to the cold, and we had less mist. And here what we did in this case was to lower down some reflective tape to the next opening of the sewer. This way the pilot can see where he needs, where is the end of his inspection. And you can see that at some parts of the sewer, you have water dripping. Sometimes you have water splashing on the drone. So the farther you go, the more risk you add in your flight. And here you even have more and more water on the lens. That makes it really, really difficult to control, knowing that also sometimes in sewer you have some winds that can push you. And here he took back the reflecting tape, and when we were in position, he had a hook to be able to take the drone out. This is another inspection with some other challenge. So here, this pillar was not in the blueprint, but as we were prepared before and we knew how large was the sewer, we knew that if the pillar in the middle, you could go straight on the side. Same thing for this piece of wood. We had to pass, well, on the side more or less, but knowing that it's a 1.10 meter sewer, we could pass on the side. So here it's it's twice or three times the speed, because we will have another very nice surprise at the end of this sewer. And it's coming in a couple of seconds. And yes, here it's coming. More or less waterfall. So we like to take risks, so we decided to fly on the side. And it went well, but we had a small surprise at the end, just after we flew on the side of it, is that water absorbed a little bit the signal. So we had signal perturbation, and we had to fly close to one of the walls to continue the inspection to have a good signal. So this was for the sewer. And here, Zach, if you can open the video of the stope, it would be great. So this is we're flying a stope. It's 220 meter long stope that we inspected a couple of days ago. And one of the, no, that was last year actually. And you will see in front of the drone, you will have some water falling from the sky. And that's completely improbable. You could never know when water will fall or what can happen. But as a pilot knew that behind him, he had no risk except the rocks. He could maneuver correctly, taking that in consideration. So sorry, this is the 200 meter high stope. You can see the altitude at the bottom left, and here you can see a couple of stones in the stope that could fall on us and also on the drone. So we were hiding at the bottom, but you can also see that there is a pretty strong drift of wind. You can see that all the dust is going up here. And you will see another, some other stones hanging up that could potentially fall. And a very interesting part of this video will be at the end in a couple of seconds when we try to fly out of the stope, so from the bottom. So here you can see what the altitude on the left side. And so now I'm flying back down, and so I'm running out of battery, but I'm at 30 or 40 meters, so it's not too bad. I fly pretty quickly down. I'm trying to do photogrammetry in here, so that's why I'm aiming up, because I need to have a right coverage of the facility to be able to build a 3D model after that. But the interesting part is when I'm trying to go out, actually the wind picked up pretty strongly. So you can see that the dust the drone is creating is actually going up pretty fast. And there is so much wind that I have trouble to go down actually. So I will be switching my flight mode. Oh, the video disappeared on my side, but Zach,
maybe,
you still have the video?
I guess that was the end of the video. So it could be that the version that I got was cut short for some reason, but that's the entire video that we have, unfortunately.
Oh, wow.
Sorry, Charles. Yeah, that looks like that's all that we had, unfortunately.
Yeah, no problem. But what I wanted to show there is that at the bottom of the slope, when we tried to fly out, it was so windy that the stabilization had trouble because I could not fight the wind enough. So I switched to the mode where it's not stabilized, and I had to switch even to sports mode to be able to fight the wind and fly out of the slope. So again, we knew that it would be some wind, but we would never imagine that we would have more than 30 kilometers per hour of wind in an indoor facility. But as we are running out of time, you can take over, Zach. It's what I wanted to say, more or less.
Excellent. Thanks so much, Charles, and really appreciate you giving us some real life examples of what could go wrong and how planning helps you be ready. Thank you so much. Eli, if you can turn on your camera and microphone, we'll jump into the Q&A. And I just want to let everyone know, we apologize for running behind, but we will go over a little bit to try to answer everyone's questions. Before we answer questions, you'll see on the screen, we have a bunch of webinars that we've done before. If you'd like to go and peruse our previous webinars, you can find them on our website under the events and webinars page. And that includes the webinar we did that was part 1 of this part 2 series, which is at the bottom of the slide here on the screen. All that being said, let's dive into the Q&A. One thing I want to note to everyone, and I'll send you a link when we email you with the recording. Eli mentioned the challenge of data localization when you're doing inspections. We actually just rolled out this week on Monday a new version of our inspector software. It's Inspector 3.0 that has a data localization feature so that you can create a sparse point cloud shortly after you conduct your mission. You collect your visual data. It takes 20 to 40 minutes to process and shows you exactly where your points of interest are. So you can pinpoint the location of your defects shortly after you collect visual data with the LEOS 2. So that will be included in the email we send everyone. I just wanted to mention, we know that's a big pain point for inspectors to localize, where those defects are that you might have found or identified when you're reviewing visual data after you've collected it. We've got a solution for that. So again, we'll send you more information via email. All that being said, let's take a few questions. So we have a question from David, and Eli, I'll direct this one to you first. David's wondering, how do you recover damaged drones from COT tanks and other enclosed areas?
I think this is actually also, I mean, not to just pass it over to Charles, but I think Charles also has some experience with different use cases or what's been done in terms of recovery. I mean, I think that one thing that has been that can be done, and we consider in some operations, is using fishing line. If there is a situation where, like, fishing line being like very, very, very thin and flexible line, where if if the drone is for some reason not able to get out or gets stuck, that we can use it to kind of, it's attached and goes with the drone the entire time that it is flying, and it can be used to sort of like pull it off of an obstacle, or if it's been impaled by something. There's cases like that. I think that Charles will also be familiar with, like in underground mines. I think that that's something that's been done. One thing to note is that the fishing line also does create its own risks, because the drone can also, like, get caught on the line, and you'll have a line that's in the asset. So it is also something to consider whether it is feasible. I think, Charles, do you have anything in terms of on this subject?
Yeah, there are a couple of things that have been done in the past. We used a good old fishing line and a hook at the end when we fly in a silo. That is a good way to recover a drone if it's right under yourself. What we did a couple of times too, it's kind of an interesting method, I would say, that we fixed a fishing line and a hook under a drone, and we flew the drone over the other drone who was stuck, and then we were taking back the drone like that. But it's important to mention that very often we fly in remote space very, very far from any accessible area. And sometimes the drone might stay on place because it's too expensive to make a longer shutdown, or it doesn't worth it because it's too risky for any means of recovery. This is why actually a good preparation and making sure that your pilot is well trained and can recognize risk is very important.
Thank you both. Question from Marco, who's asking, can you record the flight path so you can repeat it multiple times exactly as you first flew it?
As you said, Zach, Inspector 3.0 will show you the exact trajectory of the drone. So it will, if you make a point of interest, it will show you exactly where the drone was when it took the point of interest, which orientation had the camera. So it will not do it automatically. You will have to pilot it, but you will be able to see exactly where the drone was when he took the point of interest.
Perfect, thank you. We have a question from Andrew who's asking, what app do you usually use for inspection documentation? And I think that would be our inspector software, at least when you're flying the Helios 2, is that right?
What we use, yeah, we use our inspection software because in Inspector, you can just put all your point of interest, put the name of the point of interest, the criticity of the problem, you can make measurement, then you just click on create reports and it will take all your picture in PDF or in Word format and you have your form like that. But Ellie, you have another experience, I think, with that.
No, I would just say, I mean, I think that there is starting to become a proliferation of sort of third-party softwares for sort of the actual like housing the actual digital asset, and then all of the inspections that are done on top of that at different points in times. You know, like digital asset management platforms. You know, we're aware that you know, like a company that is in Southeast Asia called Aerodyne that is doing that, and there are others, you know, like Bentley is another company that has developed software for that. But I would also go back just in terms of the actual raw data and then turning that into an inspection report. I was going to say the same thing. The Inspector app by Flyability, I can't believe that it's free. I mean, it really is truly very powerful software for any inspector in terms of just being able to take data and then automatically generate an organized report with all of the inspection annotation and measurements in Word format. It really, really is very powerful, and I'm quite excited about the version 3 that is currently in beta.
Awesome. And one note on that, we've had some questions about how measurements are derived after, you know, collecting visual data during a flight. It's using that software, so that's the answer to those measurement questions. We have a question from Tim, and I would imagine those who might be on the webinar who are on the asset owner side, the asset management side, have this question. So Tim's asking, you mentioned that the drone pilot isn't usually provided by your company. What level of skill would be required? How much training do you believe would be required before becoming proficient in using the drone for inspection? So of course, Eli, your company is a full service company, right? You show up, you have the drone, you do the inspection. So I think Tim's wondering that this sort of classic question of, do I build a program in-house? Do I hire a third party like Halo Robotics? I guess, Eli, could you speak to that sort of question of, I guess, not just whether to go in-house or hire a third party, but what's required to actually use the Helios 2 proficiently to conduct an inspection?
That's a great question. I mean, I think training is very important, but I do really believe that you know, that it is you know, the key point about the drones is that what makes them powerful is that they are increasingly straightforward and to use, in addition to being very advanced and getting these good results. So, we find that people who have a little bit of experience with video gaming, have a general aptitude for drones, but it's by no means restricted to that. I think as long as the key point is in terms of like preparation and documentation, some of the other factors that go into an operation are also attended to. The actual drone flying part can be addressed with a couple of days of training. So the flyability basic training is a one-day training, and that is required to activate the warranty on any flyability drone. And then flyability provides the aerial indoor inspection methodology training, which is a 2-day training program. And I myself did that exact training program with no prior experience flying the Helios 1 or the Helios 2 with Charles, and was able to come back to Indonesia and train with our team, and we've been using it very proficiently since then. So Charles, I think, do you have anything to add on that?
Yeah, I would have maybe one thing. I would say depend your use cases and your industry, meaning that if you have 200 tanks who are similar and that's the only use case you have is inspecting these tanks every week or one tank every week, it's going to be extremely easy because your pilot will learn how to fly in this single environment, and that's all. It's easy. What's difficult is to have a professional pilot like the team that LI have or our pilots who are able to fly well in every kind of environment. So it really depends on your use case. You can have simple use case and very, very difficult and complex. The training will have to depend on that.
That makes a lot of sense. And of course, I think a lot of companies experiment with hybrid models where they might have someone who's in-house, but they might bring in a Halo Robotics for a high risk or a highly skilled mission. I think there's all kinds of models people are using right now as they sort of figure out what the appropriate drone program is for their company. So thank you guys both. We have a sort of specific question from Julio, and then we just have one more question and that'll close this out. Julio's wondering, do either of you have experience in using drones for inspections in mining at high altitudes like 4,500 meters above sea level?
We work with a very, very large underground mine that the mine is located 2,700 meters, 2,700 meters to 3,300 meters above sea level. And this is, I brought it up earlier in the presentation, the altitude is actually a real factor in terms of the Helios 2 flight batteries. The number one thing is it's a perfectly feasible situation. In terms of the drone is still safe to operate, but it is the way that impacts on the operations is that it reduces the battery time that we plan. So like where typically, an Helios 2 battery will give you 11 minutes of total flight time, we budget 8 in terms of 8 minutes per battery. You would reduce the flight time by about a half when you're working at high altitude. But still, I mean, the one thing I would note is, when you say like 4 minutes, like 4 minutes of flight time, like actually a lot can be done in 4 minutes. And, some of the use cases in underground mining, like stopes or draw points that are blocked, or like ore passes, for example, like quite a bit can actually be accomplished within a 2-minute flight. We've done demonstrations for customers that, literally a 2-minute flight has produced, a 27-page inspection report. So it's still definitely able to be operated safely and produce high value in very high altitude mines above and underground.
Excellent, thank you. And our last question is also from Andrew, who's asking, and Charles, you might know, or I'm not sure, Eli, you probably know too. Andrew's wondering, do we have some assurance for our drones? Is it realistic to expect compensation if there's an accident, or what might that look like?
So there are But we have some customers who actually take an insurance separately on the drone. And I don't know if I'm not a sales guy, but we have.
Let me jump in on this one, if I may. This is Johan with, I'm in charge of the North American region. So we do have a full coverage insurance plan that is called Flyability Protect, that we sell for $3,700 per year. It's a yearly fee, and it covers you from any kind of damage, even if it's completely your responsibility, with a deductible of 20%. So that's our full coverage insurance plan called Flyability Protect.
Thanks, Johan, very much.
Thank you.
Great. I think that's going to close it out for the webinar. I know we've already gone over by about 10 minutes. I want to thank you both so very much. I want to thank the attendees who stuck it out until the end and who had all these great questions. I especially want to thank Eli because is it 11 o'clock at night there in Indonesia, Eli?
Yeah, no rest for the wicked, Zach. So yeah, thank you very much for the opportunity to connect with you all, and I really enjoyed it. And yeah, thanks very much for your time.
Well, we're really grateful, and I know a lot of people really got a lot out of your presentation, and even more people will when they go, look at your slides, see your recording, who maybe weren't able to attend today. So thank you, and Charles, thank you so much for drawing from your personal experiences with these unexpected scenarios, right? I think we all saw in those videos things can go wrong, but if you know the size of the pipe that you're flying in, right, in a sewer inspection, maybe you can go around the waterfall. If you didn't know that, well, then you'd be stuck, right? Your battery might die and it could be a lot worse. So thanks so much, Charles, as well. We really appreciate both of you. I'm going to go ahead and end the webinar. Thanks again, everyone. I hope you have a great weekend coming up, and take care out there.